Hi everyone, it's John Pregel. We're up here in the Whitman Sugarbush, as we call it, and today we're going to give you a tour of our sugaring process from tap to line to sap house, and talk about some of the experiments we do along the way and give you a good tour of what we do here. So we've got a nice sunny day here in late March. It was cold last night, below freezing, and today it is above freezing, and so our sap is running. We're going to get a good view of what it looks like here. We look around, about 79 trees on laterals, and they flow into a main line. And so we're going to focus in on a couple of those today. We're going to start by how we identify sugar maple trees. So we have true sugar maples here, or rock maples as they call them. We start by looking at the bark. The bark doesn't tell the whole story though. It gives us an idea of where to start. What we really want to do to identify in the middle of the winter, when there's no leaves on it, is by looking at branching pattern. And so for a maple tree to be a true maple, they have to have what we call opposite branching pattern. So looking at this tree right here, you can see that we have going up, and for every one coming off, they're opposite. There's only 3 tree species that have that. It's maple, ash, and dogwood. So that's where the bark can help you out afterwards, because the maple tree looks very different from a dogwood tree bark. And then your ash tree, if you have an ash tree, it's probably dead. We have an ash tree over here. Bark looks relatively different, but also the emerald ash borer has drilled holes in them, and the entire tree, if we look up, is going to be dead if it's in the northeastern woodlot. The branching pattern looks different from alternate. So here we have an alternate branch pattern. You can see that every node, only one comes out, and they basically alternate. That'd be your oak tree. Most commonly confused are maple and oak trees. So once we identify the tree that we want to tap, the tapping process, I don't have a video for that, but for us, basically, we're going to tie into what we call a lateral line. So looking up here, we've got our spout. Sap's actually running right now if you look closely, and that's coming down into our lateral. And that lateral will travel all the way over to our main line. We use 5/16 here, which is the standard for vacuum. And that's going to tie in to our main line. You'll see that we passed another tree. We have between 5 and 7 trees per lateral. And then that's going to travel up into our saddle. If you look closely, you can actually see the sap moving today. These little hooks here, these loops, we use these to identify where leaks might be and take some stress off of our lateral. But basically, this lateral number 6 for us here, if we were to follow that, anywhere where you would cut it, there'd be a vacuum. So there's a vacuum following this line all the way down. We'll walk the whole thing, but it's all being sucked out of the tree. And so on days where it starts to slow, we can draw more sap out, and it also sucks it all the way to the sugar house for us, which is really nice. But we have these problems with squirrels here. And the squirrels like to chew holes in the lines. So if there's a hole in the line, the sap would be coming out of that hole instead of into our main line. And so these loops provide us with an idea of whether the vacuum's actually going, because we have 14 lines here. So if you follow each line, it'd be nice to know where that hole is. And that's one of the things our kids do, is they'll come out and they'll walk these lines every day, and they can identify whether there's a hole or not in the line before they even walk that line. And then they're just looking for vacuum afterwards, whether it's coming out. So like we said, we have 79 trees on taps here, or on lines going into this main line, and that main line is going to travel all the way to school for us. I'm going to walk the majority of it for you right now, and I'm going to take a swing by and take a look at some other trees as well. So either fast forward or hang in until we stop. And of course, we have to give this is Dexter, give the obligatory pet to him. All right, come on, bud, let's take a walk. Got a really nice sap flow today. I don't know if you can see it in the video, but it's flowing really well down these lines. Should have a lot of sap for us. Right there's a great example. Really see it kind of getting sucked down in there. Here's a spot we can highlight. The squirrels had chewed a hole in our main line, and so we had to cut, hit with a blowtorch, and then splice in a connector here. Something that me and the ag teacher did a lot of this early spring. But what's great is when they seal really nicely, you can see the sap basically getting drawn right through this by the vacuum and going right down to our sap house. One thing we struggle with here while we're walking is going downhill. Our sugar house is almost level with our actual lines, and so all of this is meant to be going downhill, but it's really hard to keep going like that. As things expand and contract with heat and cooling, they drop down, and then when it fills up with sap, it's a lot of weight. So we tried to fix that by tightening all the lines here, going to trees. Another good project for kids is going with a level and trying to figure out where all those are. All right, so we're gonna take a quick shortcut. You can see our line goes that way to the sugar house. But I'm gonna cut through here and show you an experiment my students are working on. Every year in my environmental science class, we have them set up an experiment and collect data and then come to some sort of conclusion based upon that data. And so one of the things we're looking at this year is spout technology. So reaching way back, Native Americans been tapping these trees for thousands of years. And they usually used a tomahawk. They would cut a splice into the tree, let it drip down a stick into a birch bucket. And fast forward to 2025, there's a lot of different technology for the size, the type of the spout that's coming out of the tree to collect that sap. And so this year we're looking at 3 different types of spouts. We have a regular spout with a check valve. That's this one. Basically there's a little ball in there, and when the pressure's coming out from the tree, the ball will go out and it allows the sap to come down. So it's hard to see with this one, but the sap is actually traveling down right now into our bucket. There's a little drop coming. There you see it. And the idea is that when it freezes tonight, if it freezes tonight, that the tree, when the sap starts running back down the trunk, can actually draw this back up through vacuum into the tree, and that check valve will close. It's supposed to keep you from losing sap. So that's one type. Another type we have is called a sap master. It's relatively new, and the idea with this one, and I only have 3, I apologize I can't show you out, but at the end there's a hole. At the end of the spout there's a hole. Let me grab one in my pocket. So here's our check valve one. And there's one hole at the end, and then the little ball. The sap master has a hole here and it has a hole on the bottom, and it's supposed to increase your yield of sap. Same length, everything else is the same, but it has 2 holes initially to try to get into that sapwood. And so they claim to collect 20% more sap than regular spouts. So the kids are collecting. That one needs to be emptied, obviously. And then our third spout type is called a barbed spout. That's on this tree up here. The barbed spout has little barbs on the end, and it's much shorter. If you actually look at the length of just our check spout and our barbed spout, it's much shorter. And the idea there is that this spout goes not as far into the tree, and the tree can use those barbs to grip it once it starts healing, and you should be able to collect more from the sapwood versus too far into the tree trunk. So anyways, the point being that with this experiment, my students are set up, found 3 different trees. We actually did 6, we did 2 of each spout, that are relatively the same size, they have relatively the same canopy cover, and they tapped all 3, and they're collecting every time it runs how much sap they collect and the sugar concentration of that sap to see if there's a difference. Now, they know, and I've explained, it's not a perfect experiment, but it really taps into that engineering and design and experimental. I remind you that most of what people did this for a really long time was this type of spout here that carried buckets, just the old aluminum. We try to get every class to have some sort of ownership. So not only do we collect with those buckets, we have a couple classes that tap using bags as well. So here's our bag, and this has an aluminum spout. And this one's perfect because you actually see it dripping right now. Let's let it collect right into our bag. This bag needs to be collected. I'll take this in with us. It's running really well today. And we measured the sugar concentration earlier. It's coming out at over 2%, which is fantastic. Should give us a good amount of syrup as we boil. All right, so I'm gonna come back for that in a few minutes. I'll take you down to the sugar house and show what we've got.
You can see one of the biggest problems we have. So right here,
we're looking across straight. Sugar house is kind of up on that hill up there, and so we have this line going from here across. It's a big dip, and as it gets warmer, we end up with these little loops in them. Like right there. So that pump's just working extra hard to get it, but we're collecting lots of sap today. It's working. I think the fun part about maple sugaring with students is every year you're doing something just a little bit different. And if you have kids in 9th, and then 10th, 11th, and 12th grade, they can see those changes over time and know that science is a process, not just a done. All right, here's our bulk tank. You can hear the pump working. Take a peek inside. One math problem that we have is we're having kids this year figure out this is an oblong shape going down and up. So if we have sap up to here, how many gallons is that? This is a 3 gallon tank. It's never been full, but let's say it's up to that black line there. How much sap is that? So we've got some geometry teachers and math kids working on that. Let's head inside. Let's give a little tour inside the sugar house now. So that noise you heard, this is coming from our vacuum pump. This is a super simple design. It's literally just a gear that's going up and down, and inside there's a diaphragm. This is what the diaphragm looks like. It creates a little suction up and down. That's creating a pretty good amount of vacuum, considering you guys just walked with me how far away it is. And that's coming in to our releaser. Our releaser is what allows the sap to be dropped in, so there's not always just a suction in there. It'll drop in and suck the next amount. And if we're lucky here, we'll see, you can see a little sap there, some coming in, being released, and then working its way down out into the sap tank. Something just happened in my video. There we go. All right, so then we get into some more modern technology as well. So down here, this is our reverse osmosis machine. Reverse osmosis removes an incredible amount of water and gives an initial filtration to our system. So coming off of this, we would have just a regular water filter, and it's getting pushed through 3 different membranes with just a regular old pump. So that pump, when it creates enough pressure, and we usually set it to about 100, it'll remove the pure water from the, what we call concentrate, or permeate from the concentrate. We make a lot of connections because we have a lot of kids on wells here, and they might have an RO system to clean their water at home. And so in this case, coming out of one spout, or this spout here, would be what we call our permeate. That's pure water. If this were a well in your house, you'd want that to go to your sink. But in this case, it's actually our waste product. Cut them out of this little one would be considered maybe your dirty water. But in this case, it's allowed us to concentrate the sugars. Or in this case, like our sugars are our waste product. So if we're removing pure water, we're actually reducing how much sap we need to create a gallon of syrup. And so then this would connect over here and it would pump what we call our concentrate up into our head tank. Great connections for our RO, or as we talk to biology, we talk about AP Bio students with osmosis and like practical uses of it. Goes into our head tank. I'm gonna come around here. So our head tank will collect a bunch of sap. There's my reflection. Hi everybody. Feeds down into here, into our pan, and this is our float box. So the float box here, pretty ingenious way of when this sap evaporates, the water leaves, the sap level will drop. When that drops, it opens up this valve and lets more sap come into our pan to boil, so that we don't have to be constantly adding sap ourselves. Instead, it does the work for us and generally keeps a nice little trickle down here, so we're not overflowing. Imagine you have a pot of boiling water, you pour a cup of water in it, it'll take your boil down. And this way, it'll actually be boiling consistently to try to get as much steam as possible. So looking inside of our pan here, a regular flat pan versus this pan are a little bit different. These are called flues. This is all the raised flue, which basically means the flues come off the bottom of the pan. And these we look at in earth science. This increases your surface area of how much heat is hitting the sap, and it'll evaporate more. When you get this cranking, we can evaporate 22 gallons per hour of water off. And so remind you, if we had a 300-gallon tank sitting outside, the faster we boil that, the less time we have in here and the less energy we use. The reverse osmosis really helps with that. I'll talk more in a second about sap to syrup. But this feeds through, and as it works its way through, the sugars will condense and the liquid will become more dense. The more dense it becomes, it works its way into what we call our finishing pans. We have the same float box here. This sinks down, opens up, it'll let more sap in. As it goes up, because it's full, it'll stop the amount of sap in here. Now this works purely by density, right? So the more dense liquid's gonna be here in this pan, and it works its way from basically 2 or 4% sugar all the way down in here to this percent sugar, which we don't have finished syrup right now, so I'm not exactly sure what it is, but it's much higher, and you can see that right in the color. And how we know syrup is done is several different ways. Well, one of the ways is just simply temperature. Water boils at 212 degrees Fahrenheit. Finished syrup boils at 219 degrees. So we're looking at our thermometer here. We have a big 7. If that reaches 7, that means we're at 219 degrees. That's finished syrup. But another connection to earth science, that number can change based upon the barometric pressure of the day. Sometimes syrup boils at 218, sometimes it boils at 220. So another way we check is using a hydrometer. So we have a hydrometer cup over here, and this will measure the specific gravity of the syrup. You can see the nice little red sign right there is at 59. Finished syrup is 59 bricks when it is hot. If it's cold, it's 66.8 bricks. And ours is coming off hot when we test it. If that floats right at the red light, red sign, we have finished syrup. Let's go back to this idea of sap to syrup. This is a model one of our physical science teachers made. At 2%, which we said is roughly what it's coming out of the tree right now, in order to get finished syrup, you would need 43 gallons of sap to make 1 gallon of syrup. So this model shows there's 42 bottles of water here, and 42 gallons of water need to be removed to get to finished syrup. Now that's if it's at 2%. Like we said, if our reverse osmosis machine can take it up to 4%, now you would only need about 22.5 gallons of sap to make 1 gallon of syrup. So it really reduces, again, how much time and how much energy. If we look at the sustainability piece, we're using propane here. We can use about half as much propane. That's half the emissions, it's half the cost. And so environmentally or economically or your time-wise, it can really save a lot of time. Once our syrup is finished, we take it over here to our canner. This canner was used earlier. It's filtration, so it's just gravity fed. We filter it in. That'll remove a lot of the sugar sand, we call it. It's just an Orlon filter with some pre-filters. And basically what that's doing is it's bringing the grade up and getting rid of a lot of impurities. I have a sample up here. This is unfiltered syrup, and you can see we call that niter or sugar sand. And that's basically all the impurities that are inside the tree. It could be minerals, could be dust. When we filter it, it's going to come out a lot cleaner and look more like this color here. We then have the students grade it. The grading is based upon the color or how much light can travel through. This is everything that we've done in the last 2 years. You see these much lighter grades here, might be a golden, this might be an amber, and then we have dark and very dark. And we use a refractometer for that, and it measures how much light travels through. We connect that with our physics students as well. There's a lot of science, and I'm skipping over a lot of it, but our last process is we bottle our syrup. So here, our food science and our environmental science classes, we look at what temperature do we need to be at to safely bottle syrup. And so for us, we aim for 185. At 185, it'll kill off all bacteria and all fungal spores. When we put into our bottle at 185, put the cap on, those molecules will cool and it'll create a sealing, just like you're canning at home. All of these we connect to our science classes, and I can help definitely with more if you'd like. And once we have our syrup finished, it's ready to taste. Our second graders are coming up on Thursday to tour. We connect the Native American history, lots of connections. All right, I'm sure that's not a great video, but I think it'll take the place of students or people that can't make it. So with this beautiful sunny day, I will bid you guys all adieu. And if you have any questions, reach out. Bye.